So, good morning, everyone. This is Sekar, statistician from the Department of Community Medicine. Today, we discuss about very important topic in research. In this session, we learn about basics calculation and what are the different methods used in a sample size calculation. Let's go to the session. So, why we need to calculate a sample size in a research? You can get 50 samples or 150 samples, even it is 30 or 40. Why need to mention about how we calculate the samples in studies? So many of them not knowing idea about what is sample size, how it is estimated, and what all things we should consider to estimate the sample size. Many researcher thinks sample size is not estimated, the random number which is given by the statistician. So it is absolutely wrong. Sample size is estimated, not a random number given by the statistician. Okay? Many researchers have been talking to me. They feel like I'm giving a large number. Please reduce it, sir. I can't have a sufficient manpower or time to do this extra sample size. The thing is, we should understand the sample size is something is given by the statistician. No, it is estimated. So we know the concepts. Many people think we have a formula, we can get the sample size. Even it is a sample size calculation, they all think there is only one formula, and that is a 4p2 by d square. It is one of the formula, but it's not a only one formula. Okay, it is one of the formula, that is a 4p2 by d square. So they think, sir, we have the 4p2 by d square formula. Can I calculate the sample size for my study? So it is absolutely wrong. It is one of the formula. We have to understand what value we should put. It is a mathematical formula. 4q by d square is a mathematical formula. If you give any value, it will give the sample size, no issues. But it is a mathematical formula, but we have to understand what value we should put. Our research questions varies, research types varies, and research methods varies. For each method, for each types, we have a different type of formulas. Okay. So in this session, we are going to learn about how to calculate the sample size. What are the different types are available in a sample size calculation. So why sample size? So do we have enough sample to represent the whole population or not? We are going to research on a subset of a population. So sample size is a subset of a whole population. So we cannot take a whole population into our research, because for an example, if you are going to see the incident of diabetic tuberculosis, foot ulcer. Okay, in diabetic patients, so many patients are available in either Tamil Nadu or Pondicherry. So you cannot involve all the diabetic 2 patient into your research. It is more difficult and it is more costly, cost effective. So we are going to take a small group of set. That is a sample size. The importance of sample size is reduce manpower and finance, as well as give a optimum effect size. Okay. Here, why I mentioned a determination instead of calculation or estimation. For example, you will calculate a sample size based on the formula. The formula says your sample size is 10,000. It could be very difficult for somebody to take a 10,000 sample or 1 lakh sample. So we try to alter. Sometimes we have a looking to compare two different groups. Since the differences is very evident, the sample size might be 4 or 5 only. So at the time also we should alter. Okay. And how much confident that the results are representative or precise the total population. So prevalence of the disease in the population is 10%. If the sample size of 10 is enough to estimate the prevalence of the same in the part of population. If the sample size of 100 would be suffix. What happens if n is? That's the two condition. If the sample size is very small and the sample size is very large. Okay. So the sample size is too small, inadequately address the research question. Many of them fail to detect the clinical important differences. If the sample size is too small, and the too small of sample size will fail to detect clinically important effects in a lack of sufficient powers. So sample size has to be determined appropriately such that nobody should be questioned on whether the result has sufficient power or not to get it from a sample size. The main objective to determine the sample size to get a realistic report results. If the sample size is too large, involve the extra subject, okay, and they require more resources, manpower, finance, time, and etc. If the sample size is too large, a sample will identify statistically significant differences which have no clinical relevance. Okay, it will give the type 1 error. Okay, so we have to choose the sample size as our study settings appropriately. Otherwise, it leads to errors. So benefits of sample size. To improve precision and descriptive studies, efficient use of time and money and resources. What determines the sample size? What are the elements are involved in a sample size? So research questions are objective. Based on the objective only, we are going to pick the parameters from the research article. So many postgraduates, researchers have been met me to get a sample size. They just bring the title and objective and asking, give me a sample size. Many postgraduates take some article, sir, they did a research on 30 samples. Can I take this? So no, they have a valid justification for the 30 samples. We have to calculate or determine the sample size based on our aim and research. Okay. Sample size is not a magical number. It is determined and you have a proper justification. If you are not having a proper justification, the ethical committee will not approve the research to the further process based on the what is your research question and objective and the type of outcome. It is qualitative or quantitative. And the type of study. It is descriptive study or in a confident interval study. It is descriptive, it is a precision, and confident interval inferential or comparative study. If you are going to do a compare the two groups, it is a comparative study. And effect size, what is the differences are in the two groups in probability of type 1 error in the power of the study. Situation where sample size determination is possible. So we have two types of outcomes. Outcome may be qualitative and qualitative. So what is the average hemoglobin level among schizophrenia patients? Here they are asking average. So there's a outcome variable should be average or mean. So it is a quantitative outcome. So it is a estimation of mean. In the another case, how common is death among patients admitted to hospital for the treatment of trauma? Death can be only two possible options, yes or no. happens or not happen. How the common death among patients admitted to hospital for the treatment of trauma. Yes or no? Though it could be in a proportion or prevalence. So estimation of proportion or prevalence. Situation where the sample size determination is possible. Is treatment A better than the treatment B for the reduction of blood sugar level? So they are going to compare a two group in a treatment A and treatment B. They are giving a two type of treatment for a reduction of blood sugar level, and the differences may be in a two means. Okay, but they are going to first we are going to estimation of mean. If it is you're going to compare two quantitative variables, it is a difference of two means. And is the adherence to therapy more among who received usual care and collaborative care model? It could be differences of two proportion. Okay. And what are the two situations in the sample size calculations? One is hypothesis testing and estimation. Okay. What we are going to estimate? Estimate the estimation of mean or estimation of proportion. In hypothesis testing, that is comparison of two means, two or more means, and comparison of two or more proportion. Only two situations, either mean and proportion. If you are going to compare in a single group, estimation of mean and estimation of proportion. If you are going to compare in two or three groups, estimation of comparison differences of two or more means in comparison of two or more proportions. Before we can determine the sample series, need to answer this following question. You should ask these questions before the calculation of sample size. Why we need to, what are the things we need to know about sample size? So, what is the main purpose of the study? Why we are conducting this study? For an example, you are going to conduct a study on incident of foot ulcer among diabetic patient. So here my aim to find a incident of foot ulcer among diabetes. What is the main purpose of this study? Why you are going to this study? And what is the primary outcome measures? It is a continuous or dichotomous for an example, incident of foot ulcer among diabetic among this, it should be dichotomous, yes or no. Okay, foot ulcer present or not. What is the primary outcome measure? Is continuous or dichotomous? How will big data to be analyzed to detect the group differences? How small differences is very important to detect? And how much variability in your population? How it is evident? What is the desired alpha and beta? For alpha, we are generally taking 95% of confidence interval, and beta power of the study is 80%. Okay. So what is the sample size allocation ratio? Is it 1:1 or 1:2? What is the case control studies? We are taking 1:1. Okay. What is the anticipated dropout rate? So in the sample size calculation, the sample size formula gives the sample size as 150. Even we cannot, sometimes we cannot take it as 150. So we should add a anticipated dropout rate. Could be 0 to 20%. So main errors, what are the errors happening in a sample size calculation? Two critical errors involved in the hypothesis testing. Okay. For an example, this is a population hypothesis. This is a population hypothesis. This is a study conclusion. Errors, what are the different errors are available in testing of hypothesis? Okay. If the population hypothesis frames is true, but the study conclusion reject the hypothesis, reject the null hypothesis, though, so there will be a type 1 error, which is alpha error, false negative. And then if it is false, but we are now not going to reject the hypothesis, then there will be a type 2 error, that is beta error. So type 1 error called as alpha error and type 2 error is called as beta error. Okay. Therefore, we have chosen the optimum sample size, which strikes a balance between implication of making a type 1 and type 2 error. So, using the type 1 and type 2 error, we are calculating the sample size and get a realistic result from the sample to generate the to generalize to the population. Unfortunately, the planning of sample size calculation, we have to some idea about result we expect in the study. So let's go to the example with the formula. Sample size for estimating problems. So usually we are thinking 4p³ by d square. That's the formula. So example 1, sample size for estimating problems. A survey is being planned to estimate the prevalence of secondary infertility among couples aged 20 to 45. So here they are clearly mention about prevalence of secondary infertility. So secondary infertility is our study population, study sample, okay, among couple aged 20 to 40 age group, okay. The sample size is needed consuming that the investigator expect the prevalence to be 10%, okay. So infertility, secondary infertility among couples aged 20 to 45 age will be the investigator expect the 10%, okay. Here, how to calculate a sample size for this study? Okay. Sample size for estimating prevalence. Useful when estimating prevalence from the surgery. We need to the expected prevalence. That is already they mentioned 10%. And the margin of error, desired precision, that is D. And level of confidence interval, 95%. Usually medical field, they are taking 95% confidence interval. How the results are? It is 95% confidence to be based on the true incident. Okay. The formula is z square 1 minus alpha by 2 into p into 1 minus p divided by d square. Okay. 1 minus z square 1 minus alpha by 2 is a 95% confidence interval, the standard deviate value, which is 1.96. So example 1, z square 1 minus alpha by 2 into p into 1 minus p by d square. Here, anticipated prevalence of secondary infertility, as they mentioned, that is 10%, and 1 minus p, 100 minus p, it is 90. Okay, level of 95% confidence interval, the z value is 1.96. So margin of error precision is 5%. Using this parameters, when the d is 5%, the sample size is 139. Okay, 139 subject should be mandatorily needed to conduct this research. So z square value 1.96 the whole square, that is 3.3 3.841. So 3.841, they just mention about 4pq by t square and desired p value. And p value is 10% and 1 minus p is 90 divided by pi square. The margin of error is 5. So the total sample size, if d is 5%, it is 139. This is another situation. If the d is small, if it is d is 3%, the number of samples should be 384. When you reduce the margin of error, the sample size will be more. So previously we are calculating the sample size for a proportion. Here sample size for estimation mean. The health department nutritionist wished to conduct a survey among a population of teenage girls to determine their average daily protein intake measured in grams. The nutritionist would like an interval of 10 grams per. That is, the estimated should be within about 5 grams of the population, mean in either direction. What sample size is needed if the confidence interval is 0.95, 95% confidence interval, and the population standard deviation is about 20 grams. Okay, usually if it is a mean formula, we cannot use a mean value. We are going to use a standard deviation. The same formula instead of P and Q, 4 sigma square divided by D square. Okay, we know the sensible value for the standard deviation. They already mentioned it, 20 grams. And level of precision 5%, and level of confidence value 95% confidence interval. For 95% confidence value, the Z value is 1.96. 1.96 the whole square into 20 the whole square divided by D, that is 5 square, is 62 samples. We need to address this issue. So sample size for descriptive studies. So example meaning, a sample size of 166 subjects is needed to estimate the mean IQ among third gender in an urban area with a 99% confidence interval of 3 points. A total width is 6 points, assuming a standard deviation of 15 points. Example prevalence. An anticipated recurrence rates of giant cell tumor, bone, distal tumor, or proximal tibia was 25%. Based on the previous research, the required precision of the samples estimate was to be within the 5 absolute precision percentage points, that is a 95% confidence interval from 20 to 30. A sample size is 288 is needed. The sample size formula for testing differences in means. So n is a sample size for each group. Assume the equal size group. And z square alpha 2 alpha standard deviation of the outcome variable. And the denominator mu1 minus mu2, the differences between two means. That is our effect size. And 1 minus z1 minus beta represent the desired power. Typically, it is 0.84 for 80% power. Usually, in a medical research, we are taking 80% power for get a proper result. And 1 minus alpha by 2 represent the desired level of statistical significance. That is 1.96. Formula used to comparison to means. The most commonly used for significant alpha is 0.05. That is 95% alpha, giving 1 minus alpha by 2 is 1.96. The most commonly used value for 1 minus beta to determine the power, that is 80%, giving 1 minus alpha, 1 minus beta is 0.84. Another commonly used value for 1 minus beta power 1 minus beta is 90. The beta value is 90%. the Z value is 1.28. Okay. Based on these parameters to 1.96. See, 2 into this for Z1 minus alpha by 2 for 95%, that is 1.96, 1.96. The beta value is plus 0.84. The whole square, and the standard deviation value we already mentioned 20. Okay, it is usually used in comparison of two groups, and the sigma level. So we have to minimize the sample size, minimize the various steps we used in a sample size 2 into 7.489. If you are adding 1.96 plus 0.84, the whole square would be 7.489 into sigma square divided by differences effect size. So 15 into sigma square by effect size the whole square. The sample size of n in each group will have a 80% power to detect a significance in means of effect. Assuming that the common standard deviation is sigma, and that the test will be performed at the 5% of significant level, two-sided. Note that n is the number of subjects per group. It's not a total group. If the sample size is 150, you should take 150 in a one group and 150 in another group. The total sample size in RSS is 300. Not the total number of subjects. Also, the required sample size increase as sigma increases, as the effect size decreases. So, example 3. In a trial, to compare the effects of two oral contraceptives on blood sugar over 1 year, it is anticipated that one drug will increase diastolic blood pressure by 3 mm, 3 mercury per mmHg, and the other will not change. The standard deviation of the changes in a blood pressure, the deviation of a blood sugar level, is in a both group is expected to be 10 mmHg. How many patients are required for the differences to be significant at the 5% of level with the 80% of power? Okay, here they are mentioned the standard deviation. The changes in the blood pressure in the both group we expected to be 10 mmHg. How many patients are required for the differences to be significant at the 5% level? Okay, that is 2 into Z1 minus alpha by 2 plus Z1 minus beta the whole square into standard deviation the whole square by the differences. Okay. The anticipated that one drug will increase the diastolic blood pressure in a 3 mmHg. So the effect is 3 mm. Okay. 2 into 1.96 plus 0.84, the whole square will be 7.489. Okay. 2 into 7.489 into 100 divided by the anticipated that one drug increased diastolic blood pressure is 3 mmHg into 3 into 3, 9. So in one group, we need a 175 women's per group. So simple formula to differences in proportion. Basically, previously we are talking about the differences in two means. Now we are going to see the differences in proportion. Sample size in each group assume the equal size n. Okay, here p bar 1 minus p measure the variability similar to the standard deviation, and the effect size differences in a proportion. Effect size is mentioned about the differences in either proportion or means, and represent the desired power 1 minus beta. Typically it is 0.84 for 80 percentage. If it is 90 percentage, it's 1.28. Usually we are using 80 percentage power for the medical researches. 1 minus alpha by 2 already we know that there is a 1.96 for 95 percentage of confidence. So example, in a randomized clinical trial, the placebo response is anticipated to be 25 percentage and the active treatment response 65 percentage. How many patients are needed if a two-sided test in a 5 percentage of level is planned and the power of study is 80 percentage required? The randomized clinical trial, the placebo response is 25 percentage and the active treatment is 65 percentage. These are our main parameter to consider about sample size, 25 percentage and 65 percentage. Okay. 2 into alpha and beta values, that is 7.489 alpha and beta 9 into 0.25, that is placebo response anticipated, it is 0.25, 25 percentage, that is 0.25, and 1 minus 0.25 plus in active treatment response, that is 65 percentage, 0.65, 1 minus 0.65 divided by the differences between two proportions. In a placebo response, that is 0.25 minus in a active treatment, that is 0.65, the whole into whole square, that is 7.489 into if you simplify this value, that is 0.415 divided by 0.16, so which is 19.4. So n, the required sample size for each group is 20. So overall the population is 40. So these are all the other methods for sampling size methods are available for case control studies, in the cross-sectional study, cohort studies. So the case control studies with the binary outcome exposed or unexposed, which requires specifications of the anticipated SARS ratio and the proportion of exposed among controls, and the other methods. With the binary outcome of exposed or unexposed with the required specification of anticipated relative risk and the proportion case among exposed and unexposed. So clinical trials, randomization, RCT. There is a three type of study. One is equivalent studies and non-inferiority and inferiority study. The equivalent study, but they aim to show that the efficacy of the new treatment is similar to the existing treatment. And the differences in the two groups, it's not differed by the more than the specified amount. Both the treatments are giving the same type of result. So there is no, which one is, for an example, the differences are not, it is not equal to 0. And the inferiority studies, where they aim to be show that the new treatment is not substantially worse than the existing treatment by the specifying the non-inferiority margin. So existing new treatment, it's not substantially worse We can use the another treatment also, that is a non-inferiority studies. It is equality study, proportion of first group and the differences of both group is equal to 0, and the non-inferiority scale is less than differences. Equivalent study, we can both use the equivalent studies. So sample size statements. For a descriptive study, the estimation of proportion, magnitude and associated factors of atopic dermatitis among children in Adyar Referral Hospital, Mekelle, Ethiopia. The main aim of the study was determine the magnitude of associated factor atopic dermatitis among children in Adyar Referral Hospital, Mekelle, Ethiopia. Sample size formula used is n is equal to 4 PQ by D square. Here, why we used 4? The Z square value for 95% in confidence interval, that is 1.96. If you are taking a whole square, it is almost 3.849. So they are taking a whole as 4. The sample size was determined by using some single population proportion formula with the confidence interval of 95% and 3% of margin of error. Okay, taking the prevalence rate of AD among children, 11.1% from the study conducted mobile dermatology clinic and Ankober, Central Ethiopia, and taking a non-respondent rate as 10%, and the final sample size become 477. Let's calculate the sample size. For the prevalence rate of among children, that is 11.5. That is 11.5 into 100 minus 11.5. That is 88.15 divided by 3% of margin of error. So 3 into 3 is 9%. Okay. So 4 into 11.5 into 88.5. That is 1017.75. Divided by 9. So 4 into 1017.75, that is 4071 divided by 9. The final answer is the record sample size is 452. After adding 10% non-responded error, okay, in 452, 10%, that is 45% plus 45. Taking non-respondent, 10% of the final sums becomes 477. 477. almost 497. 497. They are taking a 477 as a total sample size. Okay. And statement for next. For a comparative study proportion, serum level of vitamin D and trace elements in the children with the recurrent wheezing at cross-sectional studies. Vitamin D deficiency is in a 40% of society. For cases, we assume that vitamin D deficiency around 60%. Sample size was calculated as a 70 for each group and power 80% and confidence interval of 95%. Okay. The sample sizes. They already know that is set 1 minus alpha by 2, that is 1.96 plus and 1 minus beta value, that is 0.84. So whole square, that is P1, the vitamin deficiency in the 40% of society, that is 0.4 into 1 minus 4 plus in a proportion of 2, that is be 60%. 0.6 into 1 minus 6. 1 minus 0.6. 0.4 divided by P1 0.4 minus 0.6 the whole square. So 0.19, 0.96 plus 0.84 is 7.84. That is 7.84 into 0.6 into 0.4, that is 0.24 plus 0.6 into 0.4, that is 0.24 divided by 0.4 minus 0.6. 0.04. So 0.24 into 0.24, that is 7.84 into 0.057 divided by 0.04. So 7.84 into 0.057 divided by 0.04. So sample size will be 12 per group. In the comparative study, mean the effect of Pinacoda and Canabinda, repeated black on weight and cardia metablactic risk factors and overweight of obese patient, Rio, North America, the clinical control trends. Sample size for method comparison. So intra-class correlation coefficient ICC. And the estimated ICC will be variable increased between the observer specified the desired precision total width of the confidence interval. Select the confidence interval as 95% example. This is a sample size formula for using intra-class correlation coefficient. The precision is D and alpha may 1 minus 1, number of rate of clusters K2 is a 2. The two instruments A and B were used to assess the central coronal thickness CTT, CCT, measurements of inter-rather reliability from previous lectures. Another instrument was 0.60. ICC correlation value is 0.60. The sample size needed to redact the same coefficient mentioned above 95% confidence interval and the 10% of precision. So as the information provided, sample reliability ICC is 0.06, 0.6, in precision 5%, and the alpha level that is 1.96, number of raters that is first is 2. 8 into 1.96 into 1.1 minus 0.6 intercluster correlation coefficient, and the total sample size is 680. You should mention like this, the statement, a sample size of 630 is needed to estimate the reliability of 0.60 between the instrument A and B with a 95% confidence interval and the 10% of precision. And sensitivity, estimate the sample size inspection must anticipate sensitivity rate, precision, and the prevalence of the disease, and the two sizes set value for the corresponding alpha. And the specificity, for an example, age is a screening tool for algorithm validation of adults aged more than 18 years population. The research wishes to estimate the sensitivity of the tool in the teenage population of age 15 to 19 years. The sensitivity and specificity done in the same age group, the other population was found to be 75% and 85% respectively. The prevalence of alcoholism is 40% in the study population. How much samples should be collected to estimate the parameters with the 95% confidence interval at a 10% of margin of level? These are the information given in the anticipated sensitivity, that is 75% or 0.75. The anticipated specificity 85% or 0.85, and precision is margin of error is 10%. You can mention 10 or 0.10. Z value for 95% confidence interval, that is 1.96. Using this formula, if it is sensitivity, the total sample size is 181. If it is specificity, the total sample size is 82. So this is the end of the session. I think you hope all understand what are the different concepts are involved in the sample size calculation. Uh, Thank you. Thank you for attending this. Thank you.